Hi guys, today I would like to talk about NumPy. So you can consider this as a tutorial series. So NumPy is a very important Python library which is used to create multi-dimensional arrays. So before we enter into the main concept, uh, here I'm declaring a height. Okay, height is the variable which is equals to I'm specifying list of values, right? So we can say this is Python list, and then displaying the values of height. So this is list, and then creating one more list, weight equals to set of weight values here, and then printing the values of weight. And when we perform this operation, weight divided by star star means height square. So weight by height square. So when we do this operation, you can see this is uh, no error, right? So the error is generated unsupported operand types for star star. So the main the logic over here is you cannot divide one set of elements with another set. So that is the problem with the basic data structures like list. So in order to solve this problem, we can go with NumPy. So NumPy stands for numerical Python. The pronunciation is numeric NumPy. You can pronounce it as NumPy, or some people also say NumPy. So it's up to you. So NumPy stands for numerical Python. So this provides more efficient storage and data operations even though the size grows. And these are the important point to be noted. It is an alternative to the Python list. So here we got errors. So we can solve this problem by creating a NumPy array. And you can do the calculation over entire array. So here it was not possible. You cannot divide one set of elements with another set, but by using this is possible, and this is easy and fast. So only one use of NumPy is to create n dimensional array. You can create n dimensional array. In short form we can say ND array. So array means you can have homogeneous items. Homogeneous means same type of elements. So that is the point to be noted. Um, then how to import this library? So importing is in this way: import NumPy as NP. What is NP? NP is an alias, short name. And one more thing is you no need to install this library if you have installed Anaconda, right? So it's a default library which comes with Anaconda, so no need to install. If it is missing, so this is the syntax: pip install NumPy. So once the NumPy is installed, and you can import it. So once imported, you can see np dot underscore underscore version underscore underscore means you are checking the version. So this is my current version. And next I'm converting height. So basically it is a list. So list is converted into NumPy array. Look at the syntax: np dot array, converting height into NumPy array. Now it becomes NumPy array, and then printing the values of this. So you can see the prefix is a array, is in NumPy array. Similarly, converting weight, the weight is also converted, then getting printing the values of NumPy weight. So this NumPy weight, NumPy height, these are the predefined user defined variables. Now I'm performing the same operation. So weight divided by height square, and storing the result into BMI. So no error has been generated, and then printing the values of this variable BMI. So these are the list of values. And one more point to be noted is the number of values in numerator and denominator should be the same, otherwise you will be getting an error. So what I tried to show is with NumPy you can divide one set of elements with the another set. So these are the important point to be noted with NumPy. So by using NumPy, you should know how to create an array. What are the different ways of creating an array, and how to know the attributes. Attributes means determining the size, shape, memory consumption, and data types. Data types of NumPy array. And then once the array is created, how do you access the elements? That is done by using indexing, or you can also do slicing. Slicing means accessing subsequence of elements. And then reshaping an array is possible, and joining and splitting of array is possible. So we are going to discuss this step by step. So first of all, how to create an array. So in order to create an NumPy array, you can use the predefined method aRange. Okay, NumPy dot aRange, which returns ND array, n dimensional array containing evenly spaced values, the numbers in sequence. So this is the general syntax. NumPy dot aRange of, you need to specify the starting position or ending position, step value, incrementation, then D type means data type. So for example, x is equals to mp dot aRange of 5. So it means we are directly giving the um, this end position. We are not specifying starting. So by default it starts from 0. You see, default it starts from 0. The stop value by default ends at the last element. Step value means incrementation. So default value for incrementation is 1. Data types you can mention, or you don't need to mention. So depends on the values or data source, the data type is decided. So creating numbers, aRange of 5 means 0 to 4 only. 0 to 4. So this is also a NumPy array. Then checking the type of x. What is the data type of x? So it is a NumPy array. And this is another example. X is equals to NumPy array of aRange of 5, but we are specifying the data type. Then it is going to create an elements of float type like 0, 0.0, 1.0, 2.0, 3.0 and up to 4.0. This is similar example. X is equals to NumPy range of, we are specifying the starting position 10 and ending position is 20 and step value 2. 2 means 1. So one element is skipped. So 10 to 20, the range of elements, and one element is skipped. So 10, 11 is skipped, 12, 13 skipped, 14, 15 skipped, 17 skipped, 18, then 19 skipped, up to 19 only. And you can also use the function linspace. So linspace means this function which gives the number of evenly spaced values between the interval. You can specify the starting and ending position also here. Start, stop, it means end, the number, end point, return step to be included or not, and D type means data type. You can check the example here. X is equals to np dot linspace of 10 to 20 means up to 19 only. It is going to create a evenly spaced of numbers up to 19. Sorry, it has taken up to 10 to 20. Okay, 20.0 also, and it is going to create the numbers, the number of elements by default 50. Okay, by default 50, 10 to 20, and all these elements are 50. You can also check the length of x. Length means number of elements. So totally there are 50. This is another example. Creating x equals to np dot linspace of 10 to 20. Number of elements are 5 only. Number of elements are 5, and you can see default data type. Default data type is float. Then another example, x is equals to np dot linspace of starting to end 10 to 20, step value number of elements are 5, end point false means you are not considering the end point. That means 20.0 is not considered. Earlier we got up to end point, but this time we are specifying end point equals to false. Then here return step, it returns the return step means difference value. You see 1.02 or 2, a number of elements 5, and we are asking to return us the return step. Return step means the incrementation value, that is 0.25. You can see the started from 1.0 plus 0.25 is 1.25 plus 0.25 is 1.5, so like this up to 2.0. Then np dot zeros. So this is a predefined method which returns the elements of zeros. So x equals to np dot zeros of 5. Totally 5 elements, and the element is 0 itself. and then x equals to numpy of same, but we are specifying the data type here. So 5 elements of integers. Then numpy dot once, it will create elements, 5 elements, and the size and the values are 1.0. 1.0 once means it gives us the value 1. By default data type is float. If you want integer, you can specify here d type equals to integer, and I'm specifying the shape here, 2 rows 2 columns. Okay, x equals to numpy dot once of 2 rows 2 columns, data type is integer. So these are the values. So these are the very fundamental ways using the predefined methods and creating a numpy array. And look at this example. I'm creating 3 arrays here. X equals to np dot random dot randint. So randint is the predefined method from the module random. It is going to give us size equals to 6, means 6 elements. You're going to have 6 elements into x1, and in x2 uh, 3 by 4, 3 rows 4 columns, and the shape range is 10 only. 10 means up to 0 to 9. And then here 3, this is 3 dimensional. X1 is 1 dimensional, x2 is 2 dimensional, where you can have rows and columns, and x3 means 3 dimensional, and the shape is 3 4 5, means 3 elements will be there, and the shape of each element is 4 rows 5 columns, displaying x1 here. So these are the elements in the range of 0 to 9, 6 elements. Then printing x2. x2 is 3 by 4, 3 rows 4 columns. These are the 3 rows 4 columns. And x3 is 3 dimensional, 3 copies of elements. This 3 elements will be there, and each element shape is 4 comma 5, 4 rows 5 columns. Then these are the properties. x3 dot nd means the number of dimensions, shape means number of elements, number of dimensions. X3 is 3 dimensional, so that is why the resultant value is 3. What is the shape of x3? 3 elements, 4 rows 5 columns. Size is totally 60. 20 plus 20 plus 20. And then checking the data type of x3, we have integer. Data type is integer 32-bit. Similarly, the other properties are x3 dot item size, the size of each item. N byte means total number of bytes taken for array. So we have totally 60 elements, 60 into 4, which is equals to 240 bytes. So this is how you can how you can create an array. So once the data structure is created, very important thing is how do you access elements. So we can use indexing and slicing. So x1, printing x1 array, then x of 0. X of 0 means 2 because index starts from 0, and x of 4 means the actually fifth element starting from 0. So this is 0, 1, 2, 3, 4, and so 4 means 2 here. Okay, x1 of 4 means 2. Reverse indexing slicing is possible. x1 of minus 4 means the last element. x1 of minus 2, second element from last 2. Then printing x2, and then trying to see how to access the elements of a 2-dimensional array. So this is a 2-dimensional array. Importantly, you need to specify the row number and column number. And if you are accessing more than one row and more than one column, then you have to use slicing properly. So you can see x2 of row 1 means this, column 2, this is 0, 1, 2, so it means 0. 0 is going to printed here. So before comma specifies the row number, after comma specifies the column number. The next two of 0, 0 means 7. 7 is replaced with 15 because you are doing the assignment. So it has been replaced. Then 1, 1, 1, 1 means this one. Row number 1, column number 1. So which is equals to 12. So 5 is replaced by 12 here. Then accessing x3. So this is x3. Totally three copies of elements are there. and each is 4 by 5. So in case of three-dimensional, you need to follow this structure. So that is, first you need to specify the element number. So which element is accessed, and then what is the row number, what is the column number. You can say element 0 means the first element. So from the first element we want a row number 2. So this is 0, 1, 2, this one. So from this column number 3. So 0, 1, 2, 3, which is 8 here. Similarly from x1 row number 1 column number 2, which is 6. So this is indexing. Then slicing. By using slicing you can access subsequence of elements, but you need to specify what is the starting position, what is ending position, and what is the step value. So if you don't specify the starting, then by default is 0, ending is by default -1. But normal syntax is this: x of, specify the start position, then stop means end position, and then step value. So based on this the elements are accessed. So creating an array x here, x equals to this. So range of A range means sequential 0 to 9. Then x of 0 to, this is starting is not mentioned, so by default is 0. So 0 to 5 means up to 4 only. 0, 1, 2, 3, 4. Then starting from 5th position, you will be getting the all elements up to the end. And then x of 4 to 7. So accessing middle element 4, 5, 6, 3 elements will be displayed, not 7, up to 4, 5, 6 only. This is step value. This is output. Then starting from 1, step value. So this is the output. Then this is reverse. All the elements are get reversed. Starting not mentioned, ending not mentioned, but step value -1. Minus means reverse. So all the elements are get reversed. Starting from fifth position, reverse. Then starting from 7th position, reverse. So these are the elements, how they are accessed. And then multi-dimensional arrays means more than 3. So this is x2. Accessing is same actually. So before comma specifies the row, and after comma specifies the column. You can use slicing also. So this is my x2 array, 2-dimensional array. Then x2 of 1, 1, 2 means up to the last, these 2 rows. And x2 of 0, 0 starting from 0th position up to 2. So this is 0, 1, and this is 2. So you're accessing the elements 4, 9. Right here specifying the step value. Here specifying the step value 3 means 2. Middle 2 rows are skipped. Then x2 of row number 1 all columns. Row number 1 all columns. This is x2 of 1 to, starting from row number 1 to last row, and the condition for column is 1 to 3, starting from column number 1 up to 3. 3 means not up to 3, which is up to 2 only. So 2 rows, 2 columns. Then no condition on start, but on end there is a condition. Then here also same, slicing 0 to 2 rows, and by default star 0 to 2 slicing. So this is also slicing, starting from 0 to 3. 0 to 3 means up to 2 only. This 0 to 1 means 2 columns. This is an example, similar example. So this is how the elements are accessed. Then here doing this, displaying the array again, and then performing reverse. Reverse step value means all the columns get reversed. Okay, all the columns are get reversed. Then again displaying x2, and then this is the starting. Before comma specifies the row. So this condition applicable on row, and no condition specified on column. So the result for this is this. Then how do you access x3? So this is x3, then slicing on x3, 0th row, 0th element, this one. From that 0 to 2 means 0 and 1, first two columns. And condition for column is 0 to 2, so that is done. Then 1 means no condition. Then this is another example. Right, we can also use for loop to access more than one array elements. So for I in range of 2 means I is going to take the values 0 and 1. Then I value is used for here from x3. So it is going to display the element from both the array, both the elements. Then accessing rows and columns, so you can also do this in this way. So this is x2, before comma specifies row, so all rows, no condition, but column is only one. Then which row, which column has been accessed? The first one. Then this is print of x2 of 0th row, column no condition. So this is the output. Then x2 of 0, which is equivalent to x2 of 0th row, no condition on column. So this is the output. Then importantly, you should know how to do reshaping. Reshaping means changing the shape of array. So convert columns becomes rows and rows becomes columns. So I'm creating a grid here, which is user defined name, which is equals to numpy dot range of 1 to 10 means up to 9. So 1 to 9. Then 1 to 9, but reshaping this into 3 comma 3, 3 rows, 3 columns. So 9 elements are there. And then 1 to 9, reshaping it into 2 comma 4. So 1 to 9 means up to 8 only. So totally 8 elements will be there. And then reshaping this array to 2 comma 4, 2 rows, 4 columns. So the number of elements and the shape has been matched. Then this is another example. MP of array of 1, 2, 3 is the array. Then reshaping 1 row, 3 columns. 1 row 3 column. Yeah, this is 1 row 3 columns. Next, you can use the predefined keyword np dot new access, means transformation is done on the column. So transformation has been done on the column. Then writing np dot new access at the place of row, then transformation on row. So this is the output. Then you should know how to do the concatenation and splitting. So we can use concat method here. Look at here, no need to import library multiple times. So x equals to numpy array of 1, 2, 3, y equals to numpy array of 1, 2, 3, and then concatenating both the arrays x and y. So this is the resultant array 1, 2, 3, 1, 2, 3 followed by 3, 2, 1. So this is the resultant array. And then creating a one more array z equals to, these are the list of values, and then concatenating 3. So this is output 1, 2, 3, then followed by 3, 2, 1, then the output of z. Then converting a, b into c. A is a 2 by 2 array, b is also 2 by 2, then concatenating a and b, then result is this. So by default the next item has been added as a row. It is not added as a column. So in order to add the second matrix as column, you need to specify the properties. Access is equals to 1. Then it is added beside. You can check the shape now. 2 rows, 4 columns. Here it was opposite. This is another example, creating a grid 1, 2, 3, 4, 5, 6, 2 rows, then checking the grid by grid. And then here we are doing this concatenating grid by itself. So the access 1 means beside. Then how to split arrays. So this is my array x, these are the elements, splitting this array into 2 parts, x1, x2. np dot split of splitting x starting from position 2. So this is 0, 1. Starting from position 2, the elements are splitted into second one. Similar example, splitting x into 3, x1, x2, x3, specifying the starting positions of second array and third array, which are here you can see 1 and 4. The second array started from 2. This is 0, 1, 2, 3. Fourth one is from fourth position. So this is splitting of an array. So creating a grid here again by using a range of 16, 0 to 15 elements will be there, and you're converting that into 4 comma 4, 4 rows, 4 columns. Here also the similar, but we are using predefined method. V split means vertical split. H split means horizontal split. V split means actually splitting an array into multiple rows starting from 2. First 2 rows into the upper part and next 2 rows into the lower part. Then you can see here left comma right. So creating a splitting grid into 2 parts. So starting from position 2. So you'll be having 2 parts here. Left part means first two columns in first matrix, next 2 columns in another matrix. So for more information, you can take help on these functions. For example, what is V-split? V-split means splitting an array into multiple subarrays vertically, means row-wise. Opposite is column-wise. So that's it. So today I'm going to demonstrate you how to create an array. Understand how to create an array, then how to check the properties of an array, and how to do indexing and slicing to access the elements of the array, and then how to do joining and splitting of array. So remember, NumPy is a very popular library which is used to store multi-dimensional data. So that's it from today's session. So you do subscribe our channel for more updates.